This is a short topic. Maximum one class is enough to complete this topic. So sulfur, the symbol for a sulfur is S, and with atomic number 16 and atomic mass 32. When we write draw the like identify the number of the proton, it has 16 protons. It is having 16 neutron because 32 minus 16, that's 16 neutron, and it is having 16 electrons. When we write the electronic structure of this, because we have to arrange the 16 electrons, so how 16 electrons are arranged? It is 2, 8, and 6. So with this electronic structure, because in the last shell there are 6 electrons, so 6 electrons in the last shell, so it means it belongs to group 6. As it belongs to group 6, it means it is a non-metal. And how many shells we are using? We are using 3 shells. So if you are using 3 shells, it means it belongs to period 3. So it is group 6, a non-metal which belongs to period 3. Existence of the sulfur. So sulfur exists as a yellow solid with low melting point. So sulfur is solid at room temperature. It is yellow in color, but the melting point is low. Why its melting point is low? Because it's a non-metal, and why even it's a non-metal but existing as a solid? So reason for that, like in a one molecule of a sulfur, it is having S8. Like example, one molecule of a sulfur contain 8 sulfur atoms. And how they are arranged? So arrange in a hexagon. Each sulfur is sharing 2 electrons. So because you can see, even though it's a simple molecule, but this simple molecule contain more atoms, so greater the number of the atoms within the structure, stronger attraction is there between the molecule. That is why the sulfur is a it's a yellow solid, but it is solid at room temperature, it is solid, but not having a too high melting point. But when you check graphite or like diamond, you find they are having a very high melting or a boiling point. The reason why the graphite and the diamond are having high melting point, because they have a, a giant structure. But in case of sulfur, it's not a giant structure, it's a finite, like 8 sulfur atoms are there arranged in a regular pattern. So this 8 sulfur atoms, stronger attraction is there. That is why it is solid, but not very high melting point. Why not high melting point? Because it is not a giant structure. Like for oxygen, if there was oxygen, oxygen is O2. So it contained 2 oxygen atom in a molecule. So what is the state of the oxygen? So the oxygen is a gas at room temperature. Why oxygen is a gas at room temperature? Because the molecular attraction is like only two atoms in a molecule, and weaker attraction is there. That's why it is a gas. But what happened in case of sulfur? As the number of the atoms within the structure increase, so the force between the molecule also increase. So basically, like 8 sulfur atoms, this is one molecule, then there will be another molecule. So which one you think will have more attraction? Sulfur, like between the sulfur molecules or between the oxygen molecules? Like this is sulfur molecule, and here you have oxygen molecule. Which one you think will have a greater attraction between the molecules? So intermolecular forces will be stronger in sulfur. And what is the reason why intermolecular forces are stronger? Because there are more atoms or more electrons are there. That's why it is having a greater attraction. So which one you think will have a high melting point? If we compare, this will have high melting point. So sulfur is having a high melting point. Where we find this sulfur, normally under the earth crust, the top layer of the earth, we find this sulfur. And how it exists, it's not existing as a compound, it is existing as a sulfur element. Different places we find a source, and like if this is the earth surface, so we find the sulfur existing as a solid under the earth crust. So mining is done or extraction. There are different ways to extract. You don't have to learn the extraction method, but existence you should know that how a sulfur exists. It exists as a yellow solid with a low melting point because it's a simple molecule with a finite number of atoms. The oxides of sulfur, there are two oxides of a sulfur. One is known as sulfur dioxide and the other one is sulfur trioxide. Sulfur dioxide is SO2, sulfur trioxide is SO3. Sulfur dioxide formation, how it is formed? So when sulfur is burned, when sulfur reacted with oxygen, so sulfur plus oxygen, this will result in a formation of sulfur dioxide. And formation of sulfur trioxide, sulfur trioxide is not a very stable compound, so it can decompose. So when sulfur dioxide reacted with more oxygen, this reaction is reversible. This will result in a formation of sulfur trioxide, and the forward reaction is exothermic. Exothermic means the reactant have more energy and the product is having less energy. So the formation of sulfur dioxide is irreversible, it is stable. Formation of sulfur trioxide is reversible. It means sulfur trioxide is not very stable compound. It can decompose back to its reactant. If I want to increase the yield, so what about temperature, high or low? Temperature should be low. That's right. And again, we use around 450 degrees centigrade, which is an optimum temperature to have a better rate and yield. And what about the pressure? The pressure should be, so we should use a high pressure because the reactant is having more particles. Like there are 3 particles of the reactant and only 2 particles of a product. So it prefer the high pressure. So we do not use too high pressure here, because if too high pressure is there, that increases the cost, because to create a pressure you have to use the fuel or you have to use the mechanical system, which result in increasing the cost of formation. So we use around 2 to 3 atm, 2 to 3 atmospheric pressure. And to speed up the rate of the reaction, we use a catalyst. So we use a catalyst, and the catalyst which we use is vanadium pentoxide or V2O5. So vanadium pentoxide or V2O5 is used as a catalyst. You have to learn the uses of sulfur dioxide. It is used to kill bacteria. It is used to bleach the wooden pulp. It is used for manufacture of sulfuric acid. So these are some uses of sulfur dioxide. You used to kill bacteria, used for bleach the wooden pulp. Like as you are using the papers, the wooden pulp is first bleached, like removing the color. Wooden pulp means, like example, you can say the extract or the juice which you obtain from the wood for making the papers. So it's like the extract from the wood which is used for preparation of the or manufacture of the paper. So to remove the color, like to make it white, the sulfur dioxide is passed. So sulfur dioxide, due to a chemical reaction, cause the decolorization of this wooden pulp, so it will become white. And on that white paper, you can have a print of different thing, so that you can have an image. Or but first thing is making it white. So how we are making it white? By using a sulfur dioxide. Then the important topic of this chapter is manufacture of sulfuric acid by a contact process. So if you want to manufacture a sulfuric acid, we call this as a contact process. What happened? How we manufacture sulfuric acid? Number one, sulfur is burned. So sulfur is burned in air, or sulfur is reacted with air. So when sulfur reacted with air, sulfur plus oxygen will give sulfur dioxide. That's the first process. Then what we do? The second thing, sulfur dioxide converted into sulfur trioxide. So sulfur dioxide is converted into sulfur trioxide. So how sulfur dioxide is converted into sulfur trioxide? The reaction is reversible. Already we discussed this part in the previous slide, that for this conversion we use low temperature around 450 degrees centigrade. We use high pressure, but not too high pressure. It's about 2 to 3 atm. And we use catalyst vanadium pentoxide as a catalyst to speed up this reaction. Now, after getting this sulfur trioxide, we have two possibilities which we can follow. The sulfur trioxide is also known as anhydrous sulfuric acid. Why it is called anhydrous sulfuric acid? Because if you add water, it will become sulfuric acid. So then two possibilities are there. Number one, like two ways are there to get the sulfuric acid. Number one is when sulfur trioxide is mixed with water. So sulfur trioxide plus H2O. This will result in a formation of H2SO4. H2SO4 is a sulfuric acid. This is one process. But what happened in this process, the problem is that sulfur trioxide is gas, water is liquid, but when this reaction occurs, it will produce vapors of sulfuric acid or fumes of sulfuric acid. Like the reaction is a violent reaction and exothermic. So when the sulfur trioxide mixed with water, this will result in a formation of a sulfuric acid, but this produce vapors of the sulfuric acid. So it is difficult to extract, like example, in a place, if we have vapors of the acid, it will be very difficult to extract. That is why we do not follow this method. But we follow the second method. What is the second method? In this one, first what we do, sulfur trioxide mixed with sulfuric acid to form oleum. But if you see what we are manufacturing, we are manufacturing sulfuric acid, and what we are adding sulfuric acid. What is the reason for this method? I will, after completing the equation, I will explain why this method is done. So basically what happened when sulfur trioxide mixed with sulfuric acid, but from where you get this sulfuric acid? If you want to prepare sulfuric acid, from where you get this sulfuric acid which you are adding? So you can have this sulfuric acid from electrolysis. Like if you electrolyze copper sulfate solution, what it result? It result in a formation of sulfuric acid. So this concentrated sulfuric acid mixed with sulfur trioxide, what it result? It result in a formation of oleum. Oleum is H2S2O7. This compound is called oleum. And oleum is mixed with water. To produce sulfuric acid. So what happened when oleum is mixed with water? H2S2O7 plus water H2O. This will result in a formation of two molecules of H2SO4. The advantage of carrying out this reaction, look, sulfur trioxide is a gas, sulfuric acid is aqueous. When you mix them, what it result? It will produce aqueous oleum. And oleum is mixed with water, so what it result? It will result in a formation of aqueous sulfuric acid. So here we have aqueous or sulfuric acid dissolved in water, but in the first step, if sulfur trioxide directly mixed with water, it will form vapors of sulfuric acid or fumes of sulfuric acid, which are difficult to extract. Now, what is the advantage? Like here we add sulfuric acid and we are forming a sulfuric acid. So basically we add only one molecule of sulfuric acid. But when oleum is diluted with water, how many molecules of sulfuric acid we are getting? Two. So it means we are getting the one which we add in the step 3, and we are getting the one which is formed in the last step. So we are getting both of them. That's why we prefer the second method, not the first method. So I will repeat what happened. Like first sulfur reacted with oxygen, formed sulfur dioxide. Sulfur dioxide is mixed with oxygen to form sulfur trioxide at 450 degrees centigrade, 2 to 3 atmospheric pressure, and in the presence of the catalyst, vanadium pentoxide. Then we have two possibilities, two ways to get sulfuric acid. We can directly mix this sulfur trioxide with water. This will form a sulfuric acid, but the reaction is a violent and highly explosive reaction, result in a formation of vapors of sulfuric acid, which is difficult to extract or separate. So we use an alternate method. What is the alternate method? A sulfur trioxide mixed with sulfuric acid. So when sulfur trioxide mixed with sulfuric acid, this will form oleum, and oleum is diluted with water, which result in a formation of sulfuric acid. But how many molecules are formed? Two. So it means we are getting the one which we add, and we are getting the one which is formed. Is it clear? We can use this method can be used to produce sulfuric acid, but the problem is that, like in the chamber, when sulfur trioxide mixed with when sulfur trioxide mixed with water, it will produce vapors of the sulfuric acid. So practically it is difficult to extract the vapors. Like it's a difficult technique to obtain the vapors from the container. That's why industrial method, the large scale production, we do not use this method, that we have a vapors of sulfuric acid. We use an alternate method in which what we do, we use sulfur trioxide and we bubble this sulfur trioxide through sulfuric acid. Like we have a container which is filled with sulfuric acid, that is H2SO4, aqueous sulfuric acid. What we do, the second stage, the sulfur trioxide which we obtain, we react this sulfur trioxide with sulfuric acid. So sulfur trioxide mixed with sulfuric acid, this will result, the result will be a formation of a compound which is known as oleum. So this will turn into a compound which is H2S2O7. That's called oleum. Then how we make this oleum turn back into sulfuric acid? By adding more water to this. If we add more water, the oleum start to decompose and form sulfuric acid molecules. Is it clear now? So we prefer the second method instead of the first one. A sulfur dioxide will form sulfurous acid, not sulfuric acid. Like example, a sulfur dioxide mixed with water, it will form H2SO3. So H2SO3 is known as sulfurous acid. And sulfur trioxide mixed with water, it will form H2SO4. So this will produce sulfuric acid. So if we want to produce a sulfurous acid, we can react sulfur dioxide directly with water. But if we want to produce sulfuric acid, practically by a contact process. So we follow this step. Then uses of the sulfuric acid. A sulfuric acid is used in car batteries as an electrolyte. It is used for as a drying agent. It is used as dehydrating agent. It is used for manufacture of a fiber. It is used for as a lab reagent, a lab chemical. But what is the difference between a drying agent and dehydrating agent? These are some uses of the sulfuric acid. But what is the difference between the drying agent? Sulfate is a salt which is formed by sulfuric acid. Like nitrate is a salt which is formed by nitric acid. Sulfate is a salt which is formed by sulfuric acid. Nitrate is a salt which is formed by nitric acid. Chloride is a salt which is formed by hydrochloric acid. So sulfuric acid as drying agent and dehydrating agent. What is a drying agent? Drying agent means when it removes the water physically. And here it removes the water chemically. What is the difference between physically and chemically? Example, you have a container, say a flask, which is filled with a concentrated sulfuric acid. Normally, concentrated sulfuric acid can be used as a drying or dehydrating agent, not the dilute one. And this is filled with sulfuric acid. The whole flask is filled with H2SO4. Example, we need a dry sample of air. There is a moist air. The moist air means like air contain water vapors. That's called a moist air. But we need a dry air. So how we can obtain a dry air? So we pass this air or a sample of air through concentrated sulfuric acid. So when this moist air passes through concentrated sulfuric acid, what will happen? The water molecule mix with sulfuric acid, so sulfuric acid will become dry and the air which does not dissolve, will escape, and at the end what we have a dry air. So this is a physical change. There is no chemical reaction here. Only like the water molecules are removed or absorbed or taken by the sulfuric acid, but you cannot write any chemical equation for this because it's a physical change, like air which was having nitrogen, oxygen, water molecules. So when you pass through it, the water molecule left here, so sulfuric acid become dilute, and the remaining air constituent, like the proportion, will escape. So you have nitrogen and oxygen escape, and you have a dry air. This is a physical change. But dehydrating agent, when we call that as a dehydrating agent, by a chemical reaction, it removes the water. Example, you have a sugar or a glucose. So this is a sugar cube. What is the chemical formula of glucose? It is C6H12O6. Different types of sugars are there, like fructose, maltose, but like C6H12O6 is there, and you're adding sulfuric acid to it. A concentrated sulfuric acid is added. So when this concentrated sulfuric acid is added to this glucose, this causes a decomposition. This causes a decomposition of the glucose molecule, and this glucose molecule will decompose into carbon, 6 carbon atoms, and it will decompose into 6 water molecules. So you can see a chemical reaction occur, that the glucose molecule chemically decompose and give carbon and water vapors or water. So when water is removed from the substance by a chemical reaction, we call that as a dehydrating agent. But when water is removed physically, there is no chemical reaction, we call that as a drying agent. So what we will observe in this, because carbon is black, so we will see a black solid is formed, and vapors are also given off. So observation will be black solid and the vapors. Is it clear? Basically, sulfuric acid does not change. What it causes, it causes a change in another compound and chemically decompose that compound into water and carbon. So we called that sulfuric acid was used as the drying agent. Nothing happened to sulfuric acid. Like if I want to write the equation for this reaction, I will not include sulfuric acid as a reactant or a product. Only thing what happened, that the glucose molecule decompose into carbon and 6 carbon atoms and 6 water molecules. So this was solid. This is basically vapor. Due to high temperature, vapors are produced, and this was a glucose molecule, a sugar. It is for solid sugar cubes. This happen. So sulfuric acid causes a decomposition of the molecule into water and the black solid carbon. So that's dehydrating agent. Yes, in the drying agent, actually there is no reaction between the water molecule and sulfuric acid. It's only just the molecule mix with each other, but there is no chemical reaction. So what happened? Like in a moist air, the water molecules are there. So these water molecules are stopped here, but there is no reaction between water molecule and sulfuric acid. Only the mixing is there. It's a mixture. There is no chemical reaction. But in this case, the sulfuric acid caused a breaking of the molecule into water. We call that as dehydrating agent. Is it clear now? Now some questions. The topic sulfur we are done. So some questions related to this. In this question, the equation for an exothermic reaction in a contact process is shown. Which effect do increasing a temperature and using a catalyst have on the rate of formation of sulfur trioxide? The reaction is exothermic. Rate of the reaction, not about the yield. Rate of the reaction. It's not about the yield. Yield will change with temperature, but the rate of the reaction is directly proportional to the catalyst, temperature, the pressure, the surface area. So both will increase. If it was a yield, increasing a temperature will lower the yield. So it's D is the right answer. Question 2. Which statement is not correct? Yeah, that's right. A is the correct answer because iron is a catalyst for manufacture of ammonia by a Haber's process. Question 3. I want participation from everyone. Temperature around 450, pressure 1.5, and vanadium pentoxide is a catalyst. So B is the right answer. Which statement about sulfuric acid is correct? Look, manufacture, it is made by Haber process. That's wrong. That's a manufacture of ammonia. Ammonia is manufactured by a Haber process. It is made in the atmosphere by action of the lightning. Basically, lightning will produce oxide of nitrogen, and when oxides of nitrogen mix with water, it will form nitric acid or nitrous acid. It react with ammonia to form fertilizer. That's true, because ammonia is the basic gas, and sulfuric acid react with the base, so it will form a salt, and that salt will be ammonium sulfate. And ammonium sulfate is a fertilizer because it is providing an essential nutrient, which is nitrogen. It react with copper metal to produce hydrogen. Copper does not react with acids, dilute acid, and in the lab we are always using dilute acids. Question 5. What is the right answer for question 5? So the process, yes, that's right, B, which involve the reversible reaction when sulfur dioxide and oxygen and vanadium pentoxide is a catalyst. Iron is a catalyst for Haber's process for manufacture of ammonia. Question 6. What is the right answer for question 6? Yes, C is the right answer because vanadium pentoxide is a catalyst for manufacture of sulfur trioxide. Question 7. The following scheme shows the 4 stages in a conversion of sulfur to sulfuric acid. Which stage is a catalyst used? So stage B, basically we are using a catalyst when we try to manufacture sulfur trioxide. Look, the temperature, I told you it's a range. It's not like exact number. It's about 400 to 450. That's right. D is the correct answer. Which statement about the sulfur or one of its compound is correct? Look, sulfur occurred naturally. Sulfur occurred naturally as a sulfur element. That's true. I told you how a sulfur exists. It exists as a sulfur solid, a yellow solid. Sulfur dioxide is used to kill bacteria in drinking water. In a drinking water, we do not use sulfur dioxide. What we use? We use chlorine to kill bacteria. Sulfuric acid is a weak acid. That's wrong. It is a strong acid with a pH 0, 1 or 2. Dilute sulfuric acid is a dehydrating agent, not dilute. That should be concentrated. So these statements are wrong. The only correct statement is A. Is it clear why A is the right answer? So this is a structure question. A sulfuric acid is produced by a contact process. The steps of the contact process are shown. The starting material, then sulfur dioxide, sulfur trioxide, oleum, and sulfuric acid. Sulfur is a common starting material for contact process. Name a source of sulfur. So what is the source of sulfur of fossil fuels? Sulfur containing fossil fuel is one of the source. Then describe step 2, give the reaction condition, a chemical equation, reference to the reaction rate, and yield is not required. So for step 2 is a conversion of sulfur dioxide to sulfur trioxide. So the equation will be when 2 molecules of sulfur dioxide react with oxygen, this will result in a formation of sulfur trioxide. Then you can mention a reaction condition around 400. Reaction condition around 450 degrees centigrade, around 2 to 3 atm, the pressure, and V2O5 as a catalyst. So these are the things which you have to mention. I wrote in short, but you can write in detail, like in words you can mention, like temperature required around 450 because the reaction is exothermic, but you don't have to mention the yield and the rate. Why it is of 5 marks? The distribution of the mark, I will show you the distribution of the marks. Look, this is a distribution of the marks, the 5 marks. 1 mark is for mentioning vanadium pentoxide is a catalyst. 1 mark is for mentioning the temperature. 1 mark is for mentioning the, 1 mark is for mentioning pressure. 1 mark is for mentioning the temperature. 1 mark is for the balance equation, and the second mark in this equation to show that this reaction is reversible. H2SO4 plus SO3. So what it result? It will result in a formation of H2, S2 and O7, which we also call oleum. In the next question, they're saying a student add an excess of sulfuric acid to copper 2 carbonate. Like copper 2 carbonate is there mixed with sulfuric acid. What will be the products? If copper, like carbonate, is reacting with sulfuric acid, what will be the products? Copper sulfate, that's one. Water will be there and carbon dioxide. So these are the products which are formed. Now, what are the observation? You have to state 3 observation. Number 1, because the solid copper carbonate is there, so the solid will dissolve, bubbles or fizz or effervescence. And what about the third observation? Because it is a transition element, so when there is a transition element, salt is formed or solution is formed, so it will form a colored solution or a blue colored solution. So the solid dissolve, fizz, bubbles, effervescence, and a blue solution will form. Yes, so colored solution and the solid size decrease and bubbles or fizz, effervescence will be there. Give the name of all the product. Already I asked this question, like copper sulfate and water and carbon dioxide will be there. A concentrated sulfuric acid has a different property than dilute. When concentrated sulfuric acid is added to glucose, a steam is given off and a black solid is formed. Name the black solid. Carbon is there. That's right. Yeah, 6 but you don't have to mention how many, because this is not the equation. So number of the carbon which are formed is not important. Only thing they ask that the black solid is, so what is that black solid? It's carbon. And what type of reaction has occurred? Dehydration. The thermal decomposition, when you have by the action of the heat, like example, condition for thermal decomposition is if by the action of heat, if I form more products, like example, if I supply heat energy and forming more product, I will call that thermal decomposition, But in this reaction, I'm not supplying any heat energy. I just add a concentrated sulfuric acid, which cause a decomposition or into carbon and water vapor. So that's why dehydration is there. So these are the questions. More questions are there, but they're similar. You can see, describe how sulfur is converted into sulfur dioxide by reacting with air. Write a chemical reaction equation for this. Sulfur react with oxygen, give sulfur dioxide. Sulfur dioxide is converted into sulfur trioxide. What is the meaning of this symbol? It means a reversible reaction. What is the catalyst used? Vanadium pentoxide. Why is catalyst used? To increase the rate or the speed of the reaction. If a temperature is higher than 450, what will happen to amount of sulfur trioxide? So it will decrease because the forward reaction is exothermic. They already mentioned here negative means the reaction is exothermic. Suggests a reason why a temperature lower than 450 is not used. If a temperature is less than 450, the reaction will be very slow. The rate will be very slow. That's why it's not too low temperature used. If the pressure higher than 1 and 2 atmosphere used, what would happen to amount of sulfur trioxide? So if we use a high pressure, then equilibrium will shift towards side where number of moles are less. So the yield or amount of sulfur trioxide will increase. What is added to sulfur trioxide to convert into oleum? So we add sulfuric acid. No, exothermic reactions also required a high temperature to increase the yield. But for reversible reactions which are exothermic, it required low temperature to have a higher yield. Rate of the reaction increases with the temperature. So if you increase the temperature, the rate or the speed of the reaction will be higher, but the amount of the product, if the reaction is reversible, the amount of product or the yield will decrease. Then what is added to sulfur trioxide to convert into oleum? So we add sulfuric acid. Do not write formula in exam, write in words like sulfuric acid. Write a chemical equation for this conversion. So sulfur trioxide mixed with sulfuric acid, this will form H2S2O7. What is added to oleum? Convert into sulfuric acid. So we add water. Write a chemical equation and one use of sulfuric acid. For in a car batteries, it is used for as a dehydrating agent, drying agent. You can mention. Is it clear? So we finished this topic, sulfuric acid. Any doubt related to this? The sulfur, basically the topic sulfur, we are done. Any doubt related to the topic sulfur? Air and water homework, weekly homework, I will discuss tomorrow. Any doubt related to the class? Okay, so I'll end this session and share the recording with you. We can make sulfuric acid by electrolysis, but the large scale, because what happened when we do electrolysis, we need electricity. So that increases the cost of manufacture of sulfuric acid. So large scale production or industrial scale production, we have to check both things, like how much it costs to prepare that thing. So using electrolysis increases the cost of manufacturing this sulfuric acid. That is why large scale production is not by electrolysis. Small scale it can be done, but not for large scale.